Okay, we'll get started. Welcome to the stream. The VOD is going to be uploaded for those of you who cannot make it to the live session, but I'm also going to upload this into to YouTube so that you can have access to the lectures. So the main purpose of this channel is to teach people how to code, teach people principles of software engineering and software development, and hopefully get the same kind of education, if you will, that you would get at a university level class, right? So with that, let's get started. Let me just check that, that the sound is okay. I think the sound looks good. All right, let's get started. Okay, so what are we going to learn here? Hopefully, not just in this lecture, but in the future lectures, which I hope I can do many of them. We're going to learn how to code. We're going to learn to write programs, learn software development, learn software engineering, right? And the beauty of this is that there's no knowledge prerequisites. So when you go to college, and let's say into a computer science degree, the same is true there, right? The professors don't expect you to know much other than maybe turn on a computer, and that's pretty much it, right? So there's no knowledge prerequisites. We're going to start from the beginning, but don't worry. I think we're going to get pretty far with very few lectures. All right, so today we're going to learn about, you can call them commands, but in reality they're methods or functions. We're going to look at repeat loops like for and while, and we're going to look at if statements. Now, again, no knowledge prerequisites, right? I'm just giving you a heads up of what's coming, and hopefully at least get familiar with the terminology here. That's all. Okay? Don't want you to get overwhelmed. And here's the challenge, and universities have this problem as well, right? So in order to just do some very basic programming, it's kind of difficult, right? There's a steep learning curve. And like I said, I mean, the challenge is there's no knowledge prerequisites, yet how can we start teaching how to program to someone? Well, we got to start somewhere, right? And we gotta climb the huge mountain, but we just gotta start somewhere, right? And we do that through abstraction of some concepts, not getting overwhelmed, right? That's the key here, right? So like I said, this video is going to go on YouTube. You can rewatch it as many times as you want, right? So that's the beauty of this, as opposed to going to a university and enrolling in a class that you only get one class, and you cannot, unless you record that class or whatever, you cannot go back and rewatch it, right? So that's the beauty of this platform and this method of teaching, if you will, right? So, but on your part, I need you guys to not get overwhelmed, right? We're going to abstract as much as we can, and initially, in order to get you to do something, to get your feet wet, we need to overlook some of the details, right? And that's just the way we got to do it. We're gonna kind of like look to the side and ignore some of the details, at least for now, so that we don't get overwhelmed. All right, so look, I mean, I think there's a lot of sites out there that actually do a good job at teaching, teaching people how to code. One of them is code.org, right? And I'm going to go a little bit through the Minecraft one. There's also this language, I think you can call it a language, that MIT made called Scratch. Okay. So let me go into the code.org Minecraft. And I know what some of you are thinking. Some of you are probably thinking, hey, wait a minute, this is like for kids. Well, yes, it is. But again, we got to start somewhere, right? And I think in here, these guys did a really good job at abstracting just, or kind of like weed out all the detail that you don't need to learn at this point, and just leave the basic concepts that that you need to learn, at least for this lecture. Okay, so I'm going to go into the Minecraft adventure here. Just check the stream real quick. Why is this not loading? Come on, Minecraft. I'm not sure why this is not loading. Okay, while this loads, I guess I should have loaded before starting the stream. But while this loads, let's continue. Let's continue on with the lecture. Hopefully it'll load in a minute here. All right, so I was talking about scratch.mit.edu. As a matter of fact, let me go to this page. Hopefully that one works. I think it's trying to load a video that they've got of some introduction. There it goes. All right, so this one is going to load. And if I click on create here on scratch.mit.edu, I'm sorry. If I click on create, just start creating here. All right, this is what I'm talking about, right? So what they do is they created a language based on blocks, right? Just blocks, right? So in here you can say I want to move certain number of steps, right? And you can change the number of steps here, maybe 5 steps, right? I want to turn, and you can see you can snap these blocks, right? And these blocks are going to get executed in sequential order, right? And then you can say in here, well, I want to turn maybe 90 degrees, right? Turn right. You can see the arrow here. There's a turn left, right? So this one is more advanced than the Minecraft one. Let's see. There we go. Now it loaded. I want to be Steve. This one's a little bit more intuitive. And I think we can. This is capturing the audio of the PC. So in here we want to get to the sheep, but you see this just really basic 3 commands, right? I can just start from scratch, so I can delete this one. Now this is important, right? You see this yellow, big yellow run button, and this one says when run. Okay, so today we're going to see kind of what that means, right? You need to start somewhere, and this is the starting point, right? I cannot delete this block, as a matter of fact, right? It just says when run, do something, right? And then I can, move forward. To get to the sheep, I just need to move forward a couple of steps, right? And that will be it. But let's just say I don't want to do that, but I want to get to, let's say, this corner right here, right? So what would I do? Well, let's just say I could get here a couple different ways, right? But let's just say I want to turn right, and I just want to execute that. It turns right, right? Now it's saying that I lost the game because I need to get to the sheep, but then I can just say move forward. How many blocks? 1, 2, 3. 3 blocks, right? So move forward, move forward, move forward, right? And let's just run that. Reset, run. All right, and then the little character moves, right? And then now I need to turn left. And then maybe move forward 2 steps. Right. So this is how a computer program works, right? You see, I'm doing a sequence of commands, right? And then I'm trying to do something. I'm trying to achieve that the character moves to this little corner, which that was what I set out to do, right? And all I had to do was just from 3 commands, right? Select the right amount or the right command and the right amount of commands, right? And just put them in sequence, right? And then we have this when run function. That's kind of our starting point. That's it, right? So that's why I was encouraging you to go to this site, right? To learn, what logic looks like, basically, right? What commands look like, and how you can achieve that, right? So look at this. Look at the MIT one. They're pretty good ones, I think. All right, let's go back. All right, so if I put kind of like those steps that we were seeing before in plain English, what would it look like, right? It would look something like this, right? Turn right, move forward, turn left, move forward, whatever, right? This is just an example, right? This is just plain English, right? And like I said, it's a sequence, right? It's a sequence of commands or steps, right? Well, what else do we know that's a sequence of steps, and then we can come up with something? Well, a recipe, right? If you want to cook something, cook a cake, for example, right? You follow a recipe, right? And you follow it in sequence, and then you come up with a chocolate cake or whatever, right? Well, another word for a recipe, it's an algorithm, right? And it comes from, the word comes from this Persian mathematician, that his last name is, it got Latinized to algorithm, but it was something like algorithm or something like that, okay? I'm probably mispronouncing that, but you get the point, right? The word algorithm comes from his last name, right? And it's basically the way a mathematician describes a recipe, a sequence of things that you follow to achieve something. Okay, right? So going back to our algorithm, right? This might be our algorithm, right? We want to get to a corner, or we want to get to the sheep, right? And just in plain English, we just do it like this, right? Well, in order for a computer to understand this, what we want to do, we need to change it up a little bit. Right, so the first thing that we might do is something like this, right? So we put the words together into one word, and we capitalized, so that we can distinguish where a word ends and a word begins, right? And then we put some parentheses and some semicolon, right? And again, don't freak out, don't get overwhelmed, right? Let's go back, right? This is plain English, right? This is a little bit of different notation, if you will. But we didn't do much, right? We just, turn the first capital letter into a lowercase letter, get rid of the spaces, put some parentheses and some semicolons, right? Just to get ourselves familiar with, computer notation, if you will, certain language notation. Now, at this step, I think it's important for you to learn something that's, I think, very, very important. This is what it's called camel case notation, right? And it's called camel case because it starts with a lowercase letter, and then, on the second word, if you will, where we got rid of the space, it starts, it's got like a little camel back, if you will, right? It starts with an uppercase letter, right? This is what it's called camel case. But it's not the only case that we use in programming, right? We also use Pascal case. And Pascal case is almost identical. The only difference is that the first letter is uppercase. Now, just as some trivia, if you will, some languages like C# are very big on Pascal case, especially on method notation like this one, right? Some other languages like Java or JavaScript, they're more of a camel case type of language, right? And it really doesn't matter, right? All that matters is that, when someone says camel case, now you know what they mean, right? When someone says Pascal case, now you know what they mean, right? And then there's one last one, so to speak. There's probably more, but the three I know is this one, snake case, right? So especially in the old days of C, even some C++, I think the standard library of C++, and languages like Jai, they're kind of big on snake case, right? So what do is that they don't capitalize any letters. They sort of keep the space, but because you cannot have the space in there, because computers don't have problems with spaces, believe it or not, right? This has to be like a single command, if you will, right? So spaces mean kind of like different things, so they put an underscore instead of the space, right? No capital letters, right? So now you know camel case, Pascal case, snake case, right? So in this class, for the most part, I want to just be consistent. I'm gonna stick with camel case. I'll still stick to camel case. All right, so we have this, our camel case notation. We added some parentheses. Don't get overwhelmed at this point. We're gonna see what those mean, right? But that's our algorithm basically. Now remember the little in the web page, the little like start here block, right, or run block. You also have to tell a computer where you need to start, right? Because in reality, you're going to have, if you do a serious program, you're going to have hundreds, thousands of, sometimes even millions of lines of code, right? But the computer needs to know, okay, well, where do I start? I have a million lines of code. What is the first line of code that I need to look at, right? And there is indeed a start method, right, in pretty much most of the languages out there. And eventually I'll go into why some of those languages don't have start methods, but again, I don't want to overwhelm you at this point, right? So how does it look like? Well, if you see, we just put this little notation up here that's like the start method for now, right? And then we have curly brace, open curly brace, and close curly brace. And we put these braces to basically say this method contains everything inside these curly braces, right? So all of these lines in here belong to the method or function the start method. Okay. Now this looks kind of ugly well, not ugly, but it's kind of hard to read, right? Because imagine you have hundreds of lines of code, and then the squiggly lines, it just gets hard to read. So what we do is we indent. We have some indentation, right? So now this is easier to read because it's indented. Now I skipped a step in here, to be honest with you, and this step right here is, believe it or not, programmers can go to war on the where do you put the open curly brace, right? A lot of programmers just put it on the same line as a method, as in here. Other programmers put it here, right? And we can go to war, and we have different coding standards, whatever. It doesn't really matter. It's just a matter of taste, right? In this class, for the most part, my preference is going to be like this, right? You put it on the next line, and obviously you indent, right? So there's a clear thing of where something begins and ends, right? There's a clear line, so to speak, here. And then you just indent the code, and this is easier to read, right? Now, because of the indentation, now you know that all of these lines of code belong to this method. Okay, but this the start method is kind of just an abstraction. In reality, it's in a lot of languages it's called the main method, right? Because you literally need to type main and then parentheses, right? So in C and C++, that start method kind of looks like this. It's int space main, right? And again, at this point, don't get overwhelmed, right? We're going to see this ad nauseum, right? This is just, you need to at first accept the notation and kind of like look the other way. Don't get overwhelmed, right? But I just want to show you what different languages do, right? So they just do this weird int main, and we're going to see what this int means and the parentheses mean at some point. But again, the concept right now that I need you to understand is that there's a starting point for the computer, and that is called the main function, and this is how you write a main function. Later on we'll get into what the int means, and etc., etc. Okay. There's another flavor also for the C++ main function that's a little bit more complicated. Now, in between the parentheses, you do this argument argc and argv, which stand for argument count and argument vector, but that's neither here nor there, right? I just wanted you to see the two different flavors of how it's done in C and C++. Again, just notation at this point. You just need to copy paste, if you will. Right? In Java, it's a little bit more verbose, right? Public, static, void, main. We know nothing about these words right now, right? So what does public mean? What does static mean? What does void mean, right? We know the main is the starting point, but that's pretty much it. What does string means, right? With a capital S and args? What does that mean? It doesn't matter. At this point, just accept the notation, right? And I'm just showing you how it's done in Java. That's all, right? So for hello world, which is the classical example of every language, right? They start with this, like public static void main, blah, 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 hello world, right? Again, don't get overwhelmed. No, not worth it at this point. This is how Jai looks. I think it's more elegant, and it's a lot more like our starting point, right? So Jai just calls it the main. Right? Notice that the stuff in the middle is not changing. The stuff in the middle stays the same. It's only this top function, how this top function is declared, right? And in languages like Python, I don't think you even need a main method. And oh, you also got rid of the semicolons there, if you see, right? Now you might think, oh, Python. I've heard of Python. That seems like the most popular language right now, and it's kind of cool that you don't need the semicolons and that you don't need a main method. Well, there's a reason why you don't need a main method, and I think you have to pay with something, right? Maybe you pay with performance, but we'll get into that, right? Just know that, yeah, it's kind of cool that you don't need the main method and you don't need semicolons and what have you. It's got other cool features, but I want to teach you why is that, what is behind the curtain, right? so that you actually understand how they're able to pull that off. Okay. All right, but just as a reminder again, right? That was a lot. Got to start somewhere. We got to ignore some of the details, but eventually we'll get to those details, right? Because one of the things that happens with a computer science degree, for example, is that the teachers just teach you all these things in the beginning, but more often than not, they forget to tell you or to go back and tell you, oh, remember how we did this? I never told you why we did this, right? And then you graduate from computer science and you have a computer science degree, and then you're importing a bunch of stuff, for example, and then you don't know why you're importing stuff because you just follow the same commands over and over, and you just thought that was normal, right? But you don't know, again, you don't know the reason behind it, etc., etc. So we're going to get there, right? So for now, we're going to ignore things, but eventually we'll get to the point where I want you to understand all the details about the program. But we got to start somewhere. All right, so let's actually write some code. For code editor, I'm going to use Visual Studio Code, which is a pretty popular code editor, but you can use whatever you want, right? You can use Notepad if you want. The cool thing about a true code editor, because Notepad is not a code editor, it's just text editor, right? But a true code editor has some what we call syntax highlighting. So as you type these commands, you're going to see like they change color on the screen, so that's helpful, right? It's easier to read the code that way. There's tons of code editors out there, so just download whatever you want. For this class, I'm going to use Visual Studio Code. In my mind, it's reasonably lightweight. You can just download it at this location right here. All right, let's get to see some code. So this is what it looks like. Now, so in order to not get overwhelmed, we're going to start with some files that I'm going to put on a link in, eventually on the VOD. But let me show them to you. Right? So you can basically copy paste this. And again, I'm going to put it, let me put it in the chat, if nothing else. We'll just put it on the chat. Right? Again, I need you to ignore this for now. Right? This is the man behind the curtain. Pay no attention to the man behind the curtain. Eventually, we'll learn everything that this is doing. Another file I want to do is this one, lecture 1. And they're not huge files, but again, I need you to ignore this detail for now. Okay. Put it in the chat, right? And you can save this on any folder you want, right? And you can just name them lecture1.html and lecture1.js, right? And after that, we're going to create our own file. This is the real meat of what I want you to do, right? So I'm going to create a text document, a text file. And I'm going to name that my first program.js. Sure you want to change the extension? Yes. Okay. And I'm going to drag it into this thing up here. And it's an empty file. Okay. Now, so probably some of you are, or some of the viewers that are going to see this, especially on YouTube or whatever, that are part of the Jai community are going to be cringing that I'm going to do some JavaScript here. But in reality is that, or my reasoning is, I need the least amount of friction at this point, right? And the least amount of friction is something where you don't have to download the compiler, you don't have to download a special IDE with the compiler, right? Again, you can use, for this one, you can use Notepad. I don't care, right? You just need a text editor, and everything else is already installed on your machine, right? If you have a browser installed in your machine, which I'm pretty sure all of you have, browser installed, Chrome, Firefox, whatever, right? Then you can follow along. You don't need to download anything else, right? Later on, when we get more serious in this class, we might explore other languages. But for now, least amount of friction, right? So if you want to download Visual Studio Code, that's it. That's all you need to follow along, right? If not, you can follow along with any text editor. Okay. All right. So we kind of have these files now, right? This is a backup, but lecture1.html, lecture1.js, and the one that I need you to concentrate on is myfirstprogram.js. Okay. All right. So let's start writing. So we're gonna write that. If you remember that function, I'm just gonna call it main. Okay. And I'm gonna open a brace, and automatically Visual Studio Code puts an ending brace in here, and you can see everything's highlighted, color coded, if you will. And we're gonna do in here, kind of like what we were trying to do. Which, let me go back here to my cheat sheet. Let's just say turn right. Right? Open parentheses, close parentheses, semicolon, right? And I'm going to save that. You can hit Control S to save it, or obviously you can just go up here and save, right? And okay, so how do we run this now? Right? Well, all you got to do is go back to your folder. Go back. Let me close this one because it's bothering me. Go back to this one. Right, and just double click on this lecture1.html, right? And you can see, depending on the browser that you have installed and your default browser, browser is just going to open, right? And so we open that browser, and what happens? My computer is running kind of slow. Page unresponsive. Wait. There it goes. And then you see this prints out, right, automatically. We turn right. Okay, cool. Just hit OK here. Let's go back to the code. Okay. What if we don't put anything? Oh, as a matter of fact, this is a good point where I can teach you to just what we call comment out code, right? So if I put 2 slashes in front, you see how it turned like purple or whatever, right? This means it's commented out. This means that that code is not going to execute, right? And we programmers do this all the time, right? So this, instead of me deleting the whole line because I'm going to need it later, I just put / in front, and now it's commented out, which means it's not going to execute. So if I just refresh this page, nothing happens, right? Now nothing happens. Come back, put it back again, turn right, save. Obviously you have to save every time. So I'm hitting Control S, or you can just save it up here. Right? Refresh, and now we say we turn right. Okay. Okay. So let's continue with our algorithm. So turn right, and then we said something like move forward, right? Open parentheses, close parentheses, semicolons, save. What happens now? We turn right, we move forward, right? So the difference between what we were doing in Minecraft, where we had a little character, you might think, oh, that was more fun. Well, yeah, but that's a web page that somebody built, right? This is your code running on your computer, right? And you probably figured this out by now. The browser is what's running this code, right? You didn't need a compiler or anything. And right now you don't even know what a compiler is, and that's okay. Or you might not know what a compiler is, but that's okay, right? And so you get the point right now, right? So if I put move forward twice, right? Save this, and we're going to move forward 2 times. Turn right, we move forward, we move forward. Pretty straightforward, right? Okay, so we can implement our whole algorithm like this. Oops. Okay. So the next thing I want to teach you is what if, so this move forward seems kind of repetitive, right? So maybe if to get to the sheep, I need to move forward like 5 times, right? And so you can see I'm typing a lot, right? Especially, let's say this was a huge world and I needed to move forward 100 times. So you might say, well, what do I do? Do I need to write 100 move forwards? No, there's a short notation where we say repeat this code these many times. And the first thing that we're going to see is that is called a for loop, right? And so the notation for that is something like the following: for space, open parentheses, close parentheses, let I equal 0. By the way, the I doesn't have to be an I, it can be whatever, but this is the convention. Most people say I as iterator. Semicolon. I is less than, how many times do you want this to repeat? Let's just say I want it to repeat 3 times, so I put a 3 in there. Semicolon. I plus plus. Okay. Again, don't get overwhelmed by this. Just flow with the notation. That's all there is to it. It's just notation. Remember, we indent the code, and now this is going to get repeated 3 times or as many times as I need, and I don't need this anymore. Okay. So again, I know we don't know what let means right now. No biggie, right? Less than, you kind of get an idea, right? This plus plus, don't worry about it. Okay. Just accept this notation for now. This is the notation that makes you repeat things, right? 3 times, 10 times, as many times as you need. I can put 100 in here if I wanted to repeat it 100 times, right? But just for example purposes, let's put a 3 in there. Let's save, go back to our web page, refresh, we turn right, we move forward again, and we move forward again. You get the idea, right? So it worked. Right? Very powerful way of just repeating whatever commands are between this, begin curly brace and end curly brace. All right, now let's imagine our little Minecraft character has to go through a maze, right? And has to go through like a random generated maze, right? And so the point I'm trying to get at is that sometimes you don't know how many times you need to repeat. You just need to say, well, I want you to move forward until you hit a wall, for example, right? And so I need you to move forward until this condition happens. Right? So how do you do that? In other words, in a for loop, you need this number right here. You need the 3. But what I'm saying is that you don't know how many times you need to move forward. You just know there's a condition at which point I want you to stop or do something different. So for that, there's another type of loop called the while loop, right? And the syntax is somewhat like this: while and then some condition, right? We don't know what the condition is for now, right? But while this condition is true, right, then do something like move forward. And that condition could be something like, well, not wall in front of you, or not whatever, right? Something that we can do right now is something mathematical. While you know, let's just say j is less than 3. Move forward. I'm going to show you, well, I already showed you the trick to comment out code, remember? So slash 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 slash, right? And let me just say let j equals 0. I'm going to start at 0 out. So this is going to do kind of like the same thing as the for loop, but I want to show you the notation, right? So this is while some condition, right? Then move forward, right? Well, let's refresh our page. Let's make sure this still works. We turn right. We move forward 1, 2, 3 times. 4 times, 5 times. Interesting. I am not. Oh, I know why. Because we're not advancing. I forgot to say in here j plus plus, or j equals to j plus 1, which is what the plus plus means, by the way, right? This statement, j equals to j plus 1, is the same thing as saying j plus plus. Okay? So what we did there is what we call an infinite while loop. That was actually a good example, because I showed you an infinite while loop. Okay? So in here, because now we're incrementing j, eventually j is going to be 3 or 4, which means j is not less than 3. Right? Let's run it again. And I closed the page. I don't know why I did that. Should have just kept it open. We turn right, we move forward, forward, forward 3 times, and that's it. Okay, great, it works, right? But again, this is kind of a bad example in the sense that, you know, it's achieving the same thing. It's like it's got a 3 in there, so we know about the 3. This is meant for something like, let's say you're reading a file, right, from the computer. So you can say while not end of file, right? Something to that effect, right? Because when you open a file, you don't know how big it's going to be. Maybe it's 1 megabyte, maybe it's a gigabyte, right? You don't know up front. You just want to read the entire file, right? A while loop is perfect for that, right? You just say, while you don't see the end of the file, keep reading, or keep doing whatever you're doing. Keep loading into memory, keep whatever, right? That's what a while loop is for. It's when you don't know how many times you need to iterate up front. Okay. All right. So we learned about, in you know, it's a short amount of time, but you already know about main functions, you know, curly braces, you know, for loops, you know, while loops, you know, these things get executed in sequence, right? We're doing pretty good. Right, the last thing I want to show you is something called the if statement. So sometimes you want to execute code depending on a condition, or you want to skip code depending on a condition. So let's comment this out. Let me show you another trick to comment things out. So if I do a /star, you see the whole thing following this /star got commented out, right? And to close where I want to end that, I just do the opposite, a */, right? So what I could have done here, instead of slash slash for every line, is the same thing, right? Started with a star slash here, and then the kind of down here. And this means this code is not going to execute. This code is commented out, right? And that's why it kind of turns dark, if you will, purple, right? Because it's going to be ignored. All right. So sometimes you want to skip code or execute code only when there's a condition, right? So for that, we have what we call an if statement. So if, this is just the syntax. So if some condition, open brace, close brace, do something. This is just an example, right? So that you get the idea. And so what's going to happen is that this line is going to get executed only if this condition is true. If it is false, the program is going to skip this. Okay. So I can say, for example, let's go back to my little example up here of J, right? I kind of erased that line apparently, but let J equals 0. I can say if J equals 3, then turn right. Right? And I want to ignore this line as well, right? So, as a matter of fact, I don't think we're going to, well, I'm going to leave them there in case you want to review what we've done, right? But we're down here. This is the code that's going to get executed, okay? For now, don't worry about this syntax. I'm just initializing what we call variables, right? So the condition is if J equals 3, then we're going to turn right. Does J equal 3? No, J equals 0, right? So it should skip this line, right? In other words, we shouldn't see anything happen, right? So when I come here, nothing happens, right? I'm hitting refresh. All right, no problem. What if I now do J equals 3, right? Now this condition is true. We're going to execute this line of code, right? Let's see if that's true. I save the file. Yep, we turn right. Awesome. Right? Okay. There's something that we part of the if statement is also something called the else, right? Else we can say move forward. And this is useful now because only one of these is going to run now, right? If this is true, then we're going to execute this line and skip this line. Only one of these can run. Okay. If this is false, we're not going to execute this, and we're only going to execute this. Right? So now this is true, which we should only see a turn right and no move forward, right? In theory. So we see the turn right. That's it. Now let's put J equals to 100 or whatever, right? It just doesn't. It's not 3. Okay. We move forward. Do we do anything else? Nope. So we skip this line and we executed this line. Right. Again, this else is useful because only one of these two is going to get executed. Now we can have more code down here. Remember, right? Let me put another move forward down here. Right? So this is always going to get executed because this is not inside an if or else, right? This is always going to get executed. But in this case, only one of these two is going to get executed. Okay, well, let's do this. So now we should see 2 move forwards, right? If we refresh this, we see the first one, we see the second one. Come back here, J equals 3. Okay, save that, refresh, we turn right, and then we move forward. Right? So we executed this line, we skipped this line because it's part of the else, and then this is just, we can have whatever we need in here. We can have a turn left, maybe. I think I have a turn left. Okay? So that's it. You know, if statements, else, you know, for loops, while loops. When do you use a for loop? When you know how many times you're going to iterate or how many times you need to execute the code that's inside the curly braces, right? And you can have as many lines of code as you want inside these curly braces, right? Same for the while loop, same for the if, right? You can have as many lines of code here. I can have multiple statements in here. Move forward. You get the point, right? Lines of code inside the curly braces doesn't matter. What matters is that it is inside the curly brace, and all of these commands, if you will, are going to execute because they're inside this curly brace, right? So if this is true, everything inside the curly braces is going to execute. If you reach the else part, everything inside these curly braces is going to execute, right? And these are inside the main, you know, the main curly braces. So whenever we invoke the main function, everything inside these curly braces is going to execute, right? So in theory, you can end up with hundreds of lines of code, thousands of lines of code inside the main function. Maybe that's not recommended, but you could if you want to. Okay. All right. Okay, so how are we doing? Let me go back to this. So we saw Visual Studio Code, for loops, while loops, if statements. Now, with this short lecture, you can in theory be pretty dangerous right now. I've basically now you know a good chunk of what programming is all about, right? Even if you did nothing else but, you know, a bunch of for loops and while loops and if statements, you can be dangerous at this point. So congratulations. If you don't feel overwhelmed at this point, you shouldn't. All right. Before we kind of end up the stream, I want to teach you a few other concepts that are, you know, key for software engineering, right? So software engineering is about writing programs that obviously not only the computer can interpret and run, but that other human beings can interpret and run, right? So it's very important that you follow a coding convention, right? Like we have in this course, right? I explained to you, where do you put the first curly brace? You put it on the same line or on the next line, right? It's important when you get a job as a programmer, right? More often than not, the group that you're working with is going to have coding standards, right? And you need to follow those. And they make you follow those not because they're sticklers or anything like that, but because uniformity in code is important, right? Because more likely than not, you know, you're going to go on vacation, for example, right? And somebody else needs to step in and read your code. And if you don't follow the coding standards, that person that is reading your code is going to freak out, right? To be honest with you, right? So you need to follow the coding standards, and you need to write programs that you know, other people can read. What does that mean, right? It means that in your method names, you know, so for example, just to give you an example, to go back to the code, right? I have a method in here called turn right that I named turn right, right? It's actually, as a matter of fact, it's on this lecture 1 code, right? You can see this is the man behind the curtain. Now I'm showing you the man behind the curtain. I have turn right, turn left, right? So imagine if I had named that method turn right, but the outcome is that you turn left. I could have done that, right? No one in their right mind would do that. But the point I'm trying to make is that maybe somebody thought, yeah, let me name the method turn right and I'm going to turn left, right? That is bad coding, right? And so again, first principle of software engineering, write code not just for the computer, because the computer doesn't care what you name these things, right? The computer is just executing zeros and ones at the end of the day. Believe me, it's just the computer just sees electricity going through or not. That's it, a 0 and a 1, right? And we'll get to that point of how that works. But the computer doesn't care what you name your methods. But it's important that it's, first of all, it's named right? I could have named this method X, for example, right? So what does X mean? Well, it means nothing, right? What is the outcome? You turn right. So why did you name it X or Y or Z? And I have seen actual programs where people name their variables and methods A, B, C, D, E, F, G, right? What does A mean? What does B mean? It means nothing, right? So choose wisely when you are coding, and you're choosing, because you're gonna come to the point where we're creating our own methods here, right? And we're choosing our own variable names. So those variable names need to be descriptive, right? And furthermore, right, what I could have done is, in here, for example, is put some comments, right? And we're going to go into the comments. We already saw a little bit, but I could put something like some comments in here. This method makes the character turn left, right? It's a comment, right? This chunk, this line is not going to get executed because I told it not to execute because I put / in the beginning of the line. So I can write whole paragraphs in here, right? Turn left by blah blah blah, right? You get the point, right? I can write as many lines of comments as I need to, and sometimes that is recommended, because when you go on vacation on your job as a programmer, somebody else comes in, somebody else is going to read this and say, oh, okay, not only did he name the method turn left, which makes it kind of intuitive, but also he's got some comments of what this does, right? And he's got like an entire paragraph, and that's good. So that's what good software engineering is about. All right, let me check on chat just to see if we got any questions so far. By the way, feel free to ask questions if you're on chat. Got no questions right now. That's okay. Like I said, I'm going to upload this to YouTube, and in YouTube, if you've got questions, feel free to leave a comment. I'll try to answer all questions. All right, the last thing that we're going to see is this is history, and it's kind of fun. So this is the first computer bug that was found. So whenever there's an error in a program, you're going to see programmers call them bugs. There's a bug in the program. The program is behaving not in the way that I intended to, right? And I think originally it doesn't really come from this. This was kind of like a coincidence, if you will, but it is in a museum somewhere, and it's like the first computer bug, and it's a moth. It's actually a moth. And so what you need to understand is that in the beginning of computers took entire rooms, right? They weren't personal computers, so to speak. They were like huge machines that took entire rooms, right? And so one of those machines, the Mach 2 or something like that, I forgot what it was called, was just behaving strangely, right? It would do some numerical calculations, I guess, and it would come up with a wrong answer. And then they were like, what's wrong? And so they actually opened the computer. I think, again, these things were huge, so you could kind of crawl in or step in or whatever, and they found a moth short-circuiting, I guess, one of the circuits. And so this was the first computer, and this is this piece is in a museum, and with the actual I think that's an actual moth underneath like a tape that she taped in here. And this was reported by one of the first programmers. I should know her name. Her name is escaping me right now. But one of the first, not only one of the first programmers, but the first important, famous female programmers. I'll have her name for next one, for the next lecture. But I wanted to leave you with this little piece of history that I think it's cool, it's important, and with that, if there's no questions, let me go back to here. Let me go back to chat. All right. Well, thank you very much. Appreciate you being here. Again, this is going on YouTube, so that you can review it anytime you want. And I hope to see you guys on the next one. I'm going to keep doing this, hopefully for a while. Thank you very much. Appreciate it, guys. Let's rate someone. Let me rate a channel. Let me rate J-Blow. Leave you with J-Blow. Right. See you guys. Thanks.